Hi, welcome to Make 2 Explore. So in our previous video about ESP ZeroCode, we have seen how to get started with this platform and how to create your own Matter-enabled IoT product. We have also seen how to flash the ESP32 boards with different ZeroCode product samples and test them using ESP Launchpad and Amazon Alexa app. In this video, let's see the detailed view about text mode configuration in ZeroCode. We will understand it using an example. For that, we will create custom ZeroCode product for channel plug board. Then we will also see its demo with different appliances. So let's get started. Please note, this tutorial is divided into two parts. In first part, we will see some theory like circuit diagram and introduction to text mode configuration of ESP ZeroCode. And in second part, we will see practical demonstration. So we suggest you to watch both the videos for proper understanding of text mode configuration in ESP ZeroCode product development. So here is the ESP ZeroCode platform. Let's first quickly create one sample product and go to configuration step. We will use product sample named plug. Before going to advanced text mode configuration, let me show you the circuit diagram again. So we're going to create a ZeroCode product, which will consist of 4 sockets, 4 manual momentary switches in the form of tactile push buttons, and 4 indicator LEDs. Okay, so this was about circuit diagram of the ZeroCode product, which we're going to create. Now let's add the custom text mode JSON config for this 4-channel smart device. So here, config version should be 3. We have seen this in documentation. Let me show you. So in ESP ZeroCode documentation guide, so you can see in properties section, possible value for product config version is 3. Okay. Then in driver section, here you have to add config for total 4 buttons, 4 relays, and 4 indicator LEDs. So you can see, we have added 12 device driver IDs. Each component, like button, relay, and LEDs, will be connected to 12 specific GPIOs. Please remember that you must give unique ID to each and every device. Then mention the type of driver, its name, as in this case we used default, that is GPIO. Then in GPIO config, you should write and assign the pin numbers. Please check pinout of your ESP32 board. If you are using similar C3 board just like us, then you can use same JSON file like us. But if you're using generic ESP boards, then update the pins as per your chip's pinout. Now let's see about the active levels. As we mentioned earlier, for button, active level will be 0. Means if we connect this pin to ground using button, the trigger-related button will get activated. Then for relays, the 4-channel relay board, which we are using here, has low-level trigger activation logic. Means it support active low TTL. Here the N-type transistors are used. So if we want to turn on the relay, we have to provide logic 0 to the base of transistors. That's why the active level in this relay driver config should remain at 0. Okay, next. For indicator LEDs driver, you must have already figured it out. Yes, we should make the active level for these LEDs to 1. Why? Since these will get activated when we provide logic high to them. Alright, so you can configure driver section like this. Now, let's move forward. The product common section. You can see this type is a common indicator. In simple way, this is just an indicator LED, which shows some different statuses while the product is getting connected to Wi-Fi or BLE or getting commissioned. So in short, it shows the status. So here we will use only one LED, and its input and output driver IDs are given here, like this. Okay? So here you can see these different keys of this object. You can go through them to understand why exactly these are being used here, and what statuses they are referring to. Alright, now next section is about product itself. So you can see the type of the product is socket, which is correct. In this smart IoT device, there will be 4 socket type objects, in which there will be 1 input button, 1 indicator LED, and 1 output relay in each socket. Right. So we have defined 4 socket types objects. So we have defined the key type as EZC product socket. Its subtype is 1. You will find more details about these different keys and properties in documentation. Now, let's see very interesting configuration section. That is a driver. So this is a socket driver input and output configurations, in which first is input. So in this case of socket, what is input? Yes, it is a button. Push button. So we have to write the ID of our button driver. That is 1000. Then next property is input mode. So what is an input mode? You can see here. If we put 0, then it will treat as a push button. And if we put 1 here, then it will be treated as rocker switch. That's why we have written input mode as 0, since we are using push buttons. Okay, next important config is input trigger type. So if you hover mouse pointer on it, you will see this input trigger type key can have 10 different values. Among them, 8 are related to button, and last 2 are related to rocker switch. So you can see if we put value 0, then trigger will happen when button get pressed down. Likewise, if we put 1, then trigger will happen when button get pressed up. Similarly, there are different triggering actions are supported, like repeat press, repeat release, long press, and hold, etc. So you can see, for our config, we have written value as 4. Why? Yes, here trigger will happen when button get clicked once. Similarly, if we would have written 5 here, trigger would have been happened at the time when button clicked twice, isn't it? Alright, so this was about input trigger type. Now next 2 keys or configs are, as earlier we have specified ID of input button driver. Similarly, we have to specify IDs of output and indicator drivers respectively. So output driver is nothing but our relay driver. And you must have been figured out that indicator is, yes, the LED. Okay, so next important config for this socket product is data model. So this is an on-off socket data model. Let's see about it in brief in documentation. So in ESP ZeroCode documentation guide, in properties table, then in product specific configurations, you have to find the information about data model for simple on-off socket. Like this. Here is the one. So you can see, there are 2 keys you have to specify in this config. First is for default power state of the device. If we put 0 here, then by default the power of this socket will be off. Similarly, if we put 1, then power will be on. So we have written 1 in our case to keep power on in default state. Next is power boot up, which means power state of the device when it boots up. So this will be very important if sometimes device get turned off due to electricity cutoff. So here, you can put 0 for always off, 1 for always on, or 2 to toggle the previous value. Or, very interesting, you can also put -1 to remember the previous value. This is cool. isn't it? So that's why we have specified the value -1 in our configuration. And we're also going to test it in our project demo. So stay tuned. All right. So in this way, we have added 3 more socket product configurations and their driver specs. You just have to overlook them, you will understand. Just remember to give correct input, output, and indicator driver IDs. Next section is test mode configs. You should keep them as it is, like these 3 default modes: common, BLE, and socket. Okay, so this was all about this JSON file. If you need more information about any config or any properties, you can always go to documentation section and learn more. You will get this modified JSON file in our GitHub repo. Links will be shared in the description of this video. Now let's see how to validate it. You can click on this to save and validate the configuration. Once configuration is validated without errors, then let's go ahead and flash the firmware into our ESP board and test it. We will do it in our system. You just follow along. We will use Matter QR code scanning method to commission this device and adding into Alexa app. You can see how we are doing it and replicate at your end. For this demo, you should have Matter compatible smart hub or controller like Alexa Echo smart speakers or Google Home Mini. You can refer our previous videos for more information. Once your device got added into Alexa app, you will see 4 different plugs. You have to name them as per your choice of appliances. All right, now let's see the practical demonstration of the project. So you can see this is all hardware assembly of the project. These all components are connected as per the circuit diagram, which we have seen earlier. Now let's overview what component included and how they are connected together. Let's start with controller board, which is ESP32C3 DevKit M1. You can use other compatible ESP boards, but you need to update the circuit according to their pinouts. This board is connected with these tactile push buttons, momentary switches. These 4 buttons will be used to control these appliances. Then these are the indicator LEDs used to show the status of appliances. Next is a 4-channel relay board, which is used to switch the load appliances. Next, this is a cooling fan, which operate at 5 volts DC. And this is a small submersible pump, which also operate at 5 volts DC. These are 2 bulbs, which operates at 230 volts AC supply. So these two are DC appliances and these two are AC appliances. So these relays are used to switch the AC bulbs. And these other two relays are used for the DC loads. This cooling fan and this submersible pump, these DC appliances are powered externally through this USB cable with 5 volts power supply provided by USB power bank. Then the AC bulbs are powered through 230 volts mains power supply. The ESP32 board also got powered via this micro USB cable with 5 volts external power. So this is all about hardware of this project. Now let's start the demo. Let's open Alexa app in smartphone and see how we can control the things via app. So our devices have been added into Alexa app, and currently they are showing their statuses are off, which is correct. Now, let's see how we can make them on and off. Let's turn on the bedroom light. And you can see light bulb will get turned on instantaneously. Similarly, let's turn on the kitchen light. And kitchen light is on. So you can see the statuses here on app, as well as on the LEDs. Now, let's turn on this cooling fan. And you can see fan is spinning. Okay, now, let's turn on the pump. And you will see the status, as well as the starting of water pumping. So this is demo of controlling the appliances using Alexa app. Now, let's turn off them one by one. Okay, now let's see the demo of the button control. Now we will use these 4 manual tactile push buttons to control the appliances. First, let's turn on the fan, and you'll see we can turn on the fan using button. You will also see the status on Alexa app and LED. Likewise, let's turn on the other appliances, and later, turn them off using the buttons. Okay, this was about buttons. Now let's see demo of voice command control through smart speaker, Alexa Echo Dot.
Alexa, turn on the fan.
Okay.
Now let's turn on the pump. Alexa, turn on the pump.
Okay.
Alexa, turn on kitchen light.
Okay.
Alexa, turn on bedroom light.
Okay.
Alexa, turn off the pump.
Okay.
Alexa, turn off the fan.
Okay.
Alexa, turn off the bedroom light.
Okay.
Alexa, turn off the kitchen light.
Okay.
Alexa, फैन शुरू करो.
ठीक है.
Alexa, किचन का लाइट शुरू करो।
ठीक है।
एलेक्सा, बेडरूम का लाइट शुरू करो।
ठीक है।
एलेक्सा, पंप ऑन करो।
ठीक है।
एलेक्सा, फैन ऑफ करो।
ओके।
एलेक्सा, पंप बंद करो।
ठीक है।
एलेक्सा, किचन का लाइट बंद करो।
ठीक है।
एलेक्सा, बेडरूम का लाइट बंद करो।
ठीक है।
So this is all about demo of voice command control. Now let's see very interesting feature of ESP ZeroCode product development platform. Let's see that if the power or electricity goes off suddenly, does this controller keep record of its previous statuses or not? For that, we will keep some appliances running. Like we will keep one light bulb and cooling fan running. And then turn off the power supply of this ESP board. Let's see what will happen if power goes off. So you can see we have turned off the power supply to all accessories. Therefore, light bulbs, relays, and LEDs are got turned off. Now let's see what will happen if power comes back again. And you can see it turned on the exactly same appliances which were running previously before power cutoff happened. This is awesome feature, isn't it? So, in this demo, you can see the custom configured product. We can control it manually using buttons. We can control it from Alexa app. And we can also control it using voice commands. The status of sockets are also indicated by LEDs. So in this way, in this video, we have seen demo of ESP ZeroCode product with modified configurations using text mode. In next videos, we will try to explore more products using different ESP32 boards. Stay tuned. Thank you so much for your support.